Hello guys, welcome to Andy Brothers. So guys, in this video we will be understanding what is dangling pointers in computer programming. So let's see. So basically dangling pointers in computer programming are pointers that pointing to a memory location that has been deleted or freed. So what I mean, so basically if suppose a pointer is pointing to a memory location and then that memory has been freed or deleted, then the pointers become dangling pointers. For example, let's see at this image. So in this image you can see, suppose a pointer is pointing to an object, and if that object get deleted, then the pointer become dangling pointer. That is, after deleting that object also we have a pointer that is pointing to that address. All right, so this is dangling pointers. So now let's see. Dangling pointers arise due to object destruction. So when we destruct an object, then dangling pointers are created when an object that has been incoming reference is deleted. So basically if an object is deleted or deallocated, then the dangling pointers arise. All right, so the pointer, so if we delete a memory location or free a memory location, then pointer still points to the memory location of deallocated memory. All right, so now let's see. The system may reallocate the previously freed memory. All right, that memory can also be reallocated. For example, suppose there is a for example suppose there is an object, uh, for example suppose 2, and a pointer is pointing to this 2, and when this object is destructed, then this pointer will be pointing to this memory location and acting as a dangling pointer. All right, so it will be acting as a dangling pointer. All right, so the system may, so this memory can be reallocated. So this will create a problem. So unpredicted behavior may result, as the memory may now contain completely different data. All right, so we are now able to understand what are dangling pointers. So let me summarize this. So dangling pointers are basically pointers pointing to memory locations that have been deleted or freed. All right, now let's move forward. So how, let's see the cases how the dangling pointers are formed. All right, so let's see the cases where dangling pointers are formed. So first way is deallocation of memory. Simple. For example, suppose we have created a pointer of size int, and suppose after so we have initialized this pointer. So after and we have freed the pointer. So after below free call, so after this free call, pointer becomes a dangling pointer because the memory has been deallocated, but the pointer still is pointing to that address. For example, suppose this address. So if we print that address, then this address will be print. Or if we make pointer equals to null, then this will not remain dangling pointer and our issue will be resolved. Now let's see the second case in which the dangling pointers can arise. So the pointer pointing to local variables become dangling when local variable is not static. What is the meaning of this? For example, suppose we have initialized a pointer and made a function call. So we will come here after the function call, and we have made a variable x equals to 5 and return the address of 5. So after returning this returning from this function, the instance of this variable x will be destroyed, because this is a automatic variable, not a static variable. So here we will have a garbage value in pointer. All right, so although memory has been destroyed, but still we have some garbage value present in the pointer. All right, so if this we can solve this problem by making the x as static. So basically our problem doesn't appear or doesn't become dangling, this pointer doesn't become dangling if x is static. So I have written code for that. Static int x equals to 5, so if we print the pointer value then it will point to the 5. All right, so now let's move forward to the third case where dangling pointers can arise. So basically, suppose if variables go out of scope, suppose we have created a function, main function, and we have declared pointer, and for example we are doing some, for example while loop, in certain while loop, we do some computations and we create local variables inside this while, and we assign the address of that variable to pointer. So after after executing this while loop, the pointer will be having garbage value because the memory in which this character has been stored would have been freed. All right, so this pointer will again become dangling pointer. All right, so we have discussed three ways by which dangling pointers can arise. So now let's move forward, and now let's see why to avoid this dangling pointers and how we will avoid this dangling pointer. Suppose here I have taken this example. I have declared a pointer p and initialized it. Now when I print the pointer, so it prints the address this 0x into 1000. So if we free it, if I free it, then this will not remain, this will remain dangling, this will become dangling pointer as the memory has been freed, but still it contains some address. So this will again print this address. Now suppose I have created another memory, another pointer, and I have initialized it. So there may be a case when it will point to the memory that has been freed already, but p is still pointing to that memory. So let me explain. By suppose there is a pointer p pointing to a certain memory location, presented address, let's say 108. All right, so now after doing this statement free p, so I have destroyed this memory, deleted this memory, deallocated this memory, but still p is pointing to this memory location. Now if I make a new pointer variable q, so there may be a case that q will also point to this location because this memory is deallocated. So we will have a problem because no two pointers can point to a same memory location in computer. All right, so this can be a problem, and this is the problem why we must solve the problem of dangling pointers. So now let's see. So I have already explained this in our code. Both p and q point to same memory location. If both points to same location, data corruption will occur. All right, so to avoid this, so to avoid the dangling pointer, we will assign p to null after freeing the memory, and then we can initialize the another pointer. All right, so basically to make a dangling pointer non-dangling pointer, we just assign it to a null value. All right, so this is how we will avoid the dangling pointer, by assigning null after deallocating the memory. And so now let's see our last point, that is the use of dangling pointer can result in number of different types of problem, including unpredictable behavior if memory is accessed. So basically I have already explained this. This is unpredictable behavior because two pointers are pointing to same memory location, which can be an issue. And another is segmentation fault when memory is no longer accessible, because that is the same issue because no two pointers can point to same memory location, and we can also have potential security risk. So basically in this video I have explained you about dangling pointers and all the related questions that we can have on dangling pointers. So hopefully you are able to cope up with me and able to understand the dangling pointers. So thanks for watching the video. Do subscribe the channel and do comments your thoughts in the comment section. Thanks for watching.